fraction, what you would obtain is going to be 1 over 90. So you need to confirm this anyway. 120 minus 2x minus 1 over 180 into 150 minus x. That is what you get. So this equals, when you integrate this, you have k1t plus the arbitrary constant. But then you observe again, you observe something very, very close here. And then what's that? Now what you'd observe is this is, when you integrate this, you have 1 over 90, the natural logarithm of 120 minus 2x. So we have negative 2 here, so it's divided by negative 2, then minus 1 over 180, the ln of 150 minus x divided by negative 1. So this is going to give us 1 over, this is 1 over 90 times 1 over negative 2, that will be negative 1 over 180, then the ln of 120 minus 2x plus 1 over 180. Then, so you note I temporarily neglected this just to finish up the left hand side. 1 over 180 into 150 minus x, the ln of 150 minus x. So this is going to give us 1 over 180, the ln of 120 minus 2x. Okay, this is going to be 150 minus x, since we're dividing anyway, so it's going to be 150 minus x. That'll be 150 minus x divided by 120 minus 2x. So this should be equal to k1 t plus c. So that's what you're going to get. So, and then on simplifying that, so what we have is, we have the ln of 150 minus x divided by 120 minus 2x equals 180 into k1t plus c. That is from here to here. I just rewrote the whole thing, but I multiplied both sides by 180 to the right hand side, and then it's here. So when you simplify that, this is going to give you, this is 180 times k1 now, and then that's give you your final answer to be, to remove the natural logarithm here, you'd have (150) minus x all over 120 minus 2x equals, so we'll have a very big constant which I'm going to call f, e to the power 180 times k1t. So that's what you're gonna obtain anyway. And then we've been able to solve this differential equation. Now the constants we have here, they are f, and then we also have k1 as our constant, which we need to clear to be able to solve this. Now the next thing is we need to use the initial condition, so we can clear k1 and f. Now the first initial condition we observe is actually an intuitive initial condition that says when A and B react, the initial amount of the chemical formed at time 0. So what I mean there is at time 0, so my initial condition now, at time, at t equals 0, the quantity of C formed, that's the quantity of the chemical formed, is going to be 0 because there's no quantity formed when the time is 0. There is no reaction yet. And then we also told that in 5 minutes 10 grams has been formed. So at time t equals 5, x of 5 is 10 grams. Now these are the initial conditions we will use to solve this. So using the first one says when t is 0, x is 0. So when x equals 0, you have 150 divided by 120 equals f e to the power 0, that's 1. So that means f equals 150 divided by 120, and this is equal to 1.25. So this is the value of f. So this implies that what we have here is going to be 150 minus x divided by 120 minus 2x equals 1.25 e to the power 180 k1t. So we still have a funny man here, that's a k1. I need to remove the k1 from there. So to remove that k1, I'm going to use the second initial condition. The second condition here says that when t is 5, x is 10. When t is 5, x is 10. So let's use that. When t is 5, so we have x is 10. That will be, so I'm using this now. So we have 150 minus 10 divided by 120 minus 2 times 10, that's 20, equals 1.25. Then e to the power 180 times, it says when t is 5. So that should be 180 times 5k1 times 5k1. So x is 10. So this should be 10. So 150 minus 10, that's 140. 140 divided by 100, that's going to give us 1.4. 1.4. So that's 1.4 equals 1.25 e to the power 900 times k1. So then the next thing is we divide both sides by 1.25 to clear this man out here. So this divided by 1.25. So what we have is 1.12 e to the power 900 k1 e to the power 900 k1. Then to find k1, take the natural logarithm of both sides. So we have 900 k1 equals the natural logarithm of 1.12. So therefore k1 equals the natural logarithm of 1.12 all over 900. So and when you compute that, you have 0.0000126. So that's what you have for your k1. So now I've been able to find a value for k1 here. So I could rewrite this whole thing now as, so let me not push it down too much. So what we have now is going to be 150 minus x divided by 120 minus 2x equals 1.25 e to the power, so this is going to be 180 times k1. Our k1 is 0.000126. So x is going to be 180 times that, which is going to be 180 into 0.000126. So we now move forward. So we found this to be our general solution. So we had from the question says, since we've been able to get the general solution to be this, the question says how much